Okay, in this video we're going to change products to sums and differences and vice versa. What I have in blue here is changing products to sums and differences. And what I mean by that is if we look at this 2 sine A cos B, that is a product. It's a product because this 2 sine A has been multiplied by the cos B. Okay? So product means multiply. And that's getting changed to a sum because I'm changing it to sine A plus sine B plus sine A minus B. Okay, so I'm changing something that's getting multiplied together to something that's getting added or subtracted together. Also, we have the vice versa of it down here. So we have a sum or a difference. Okay, difference is minus. So we have a sum that says sine A plus sine B. We have a difference that's sine A minus sine B. And we want to change that into a product. So things that are being multiplied together. And look, we have 2 sine A plus B over 2. And that's multiplied by cos A minus B over 2. So one thing to notice, or to note, when we're changing a sum or a difference to a product, so when we're going from this type of thing to this type of thing, we make sure to have the bigger angle first. So for example, down here, if I have sine 3x plus sine 5x, well, sine 5x is bigger than 3x, so we're going to change that to sine 5x plus sine 3x. Likewise, if we have 2 sine 2x cos 3x, we're going to change, we can leave the 2, yeah, that's fine. However, we're going to change the cos 3x first and the sine 2x next. Okay, a few sample questions then. So this says, express 2 cos 3x sin x as a sum or a difference. If we look at this first, 2 cos 3x sin x, if we look in our logbooks, we know we'll be using 2 cos A sine B equals sine A plus B minus sine A minus B. So that's the one we'll be using. Why? Well, because we have the cos A first, the sine B second, just like we have up here. Okay. So, just to see, that is A and that is B. So A is 3x, B is x. So we'll be left with sine 3x plus x minus sine 3x minus x. And that will be sine 4x minus sine 2x. Okay, so that's that done. Next one, express cos theta cos 5 theta as a sum or a difference. Right. Notice we don't have a 2 here, okay? But we do have cos and then cos. So this will be A and this will be B. So we'll be looking for the cos formula. Cos formula is 2 cos A cos B equals cos A plus B plus cos A minus B. Alright. The first thing we have to do is we're going to change this and this. Why? Because remember I said earlier, we usually put, or we always try and put the biggest angle first. So I'm going to say cos theta cos 5 theta is the same as, or equals cos 5 theta, not plus, cos theta. So I'll be working with this. Right. Now, we don't have the 2. Okay, we don't have the 2, so I'm going to have to redo this. I'm going to have to say a half 2 cos 5 theta cos theta. The reason I put the half there is to allow me to put the 2 there without actually changing the sum. Okay. So now I can keep the half here, and I can use this formula. Here, this one here. Remember, here is my A, here is my B. So it will be based on the formula cos 5 theta plus theta plus cos 5 theta minus theta. So we'll be left with half cos 6 theta plus cos 4 theta. And that's that done. Great. Next question. Express cos 5a plus cos 3a as a product. So now we're doing the vice versa. We're looking at doing this. Right. So it's a cos plus a cos type of question. So the formula we'll be using is cos A plus cos B equals 2 cos A plus B over 2 cos A minus B over 2. So that's what we'll be using. Okay, so here's our A, here's our B. So we'll be left with 2 cos 5a plus 3a over 2 cos 5a minus 3a over 2. That's simplified. We'll get 2 cos 2a over, sorry, 8a over 2 cos 2a over 2, which will simplify to 2 cos 4a cos a. So the next one, it's a sine minus a sine. So we look in our log books, see what sine minus sine formula is, and it is this. Sine A minus sine B equals 2 cos A plus B over 2 sine A minus B over 2. So that's the formula we'll be using. This is A and this is B. So we'll be left with 2 cos 3a plus a sine 3a minus a. This will leave us with 2 cos 4a over 2, which is 2a, sine 2a over 2, which is a. So 2 cos 2a sine a. And I suppose maybe I should put this in. 3a minus 3. Okay, so it's just saying that equals that. Right, last one, and probably the trickiest one. Show that sine 3a minus sine 2a plus sine a over cos 3a plus cos a minus cos 2a equals tan 2a. We know from earlier on that sine a over cos a equals tan a. Okay, so with that logic, we're going to try and get sines over causes to try and show tans. Okay, so if I can get a sine over a cos, I get tans, and also if I can get, I suppose, the same on the numerator as the denominator, I can cancel. So here's how we're going to start. we're going to take out the minus sign 2a. So, there we go. And we'll do something similar on the bottom. Okay. Now, if we look at this, it's adding together, and so is this adding together. I don't want that because I can't cancel if they're getting added together. So I'm going to have to change this in yellow, this sum to a product. Once I get the same product on the top and the bottom, then I can start cancelling. Okay, so basically once things are being multiplied together on the top and the bottom of this fraction, I can start cancelling. Until that point, I can't. So let's look at this first. Right. Sine 3a plus sine a. Well, what we'll be using here is this formula, and I'll write it over here. So it'll be sine a plus sine b equals 2 sine a plus b over 2 cos a minus b over 2. Okay, so that's a bit tight there, okay, but you know the formula, you see it in your logbooks. So with that in mind, this here will get changed to 2 sine, this is a, this is b, so 2 sine 3a plus a over 2 cos 3a
minus a.
So just simplifying that then,
over 2.
we get 2
minus
sine 4a over 2, which is 2a, cos 3a minus a, which is 2a over 2, which is a, and then minus sine
and then you have 2a.
And likewise we have 2 cos
3a
4a over 2, which is 2a,
plus a
cos
over
3a
2,
minus a, which is 2a over 2, which
cos
is a
3a
minus cos
plus
2a.
Sorry, minus a over 2. Minus
Again, what I wanted to
cos
look at
2
like is
a.
tan 2a. Okay, so I really need everything to cancel except the sine 2a here and the cos 2a. If I do that, sine 2a over cos 2a is tan 2a. So how can I manipulate that? Right, I'm going to start just factorizing. So if I take out the sine 2a, okay, now what do I have to multiply sine 2a by to get back to this? 2 sine 2a. Well, I have to multiply it by cos a. Actually, no, we'll do this. Sine 2a, take it out. We have to multiply that by 2 cos a. So that multiplied by that will give me the yellow. And then how do I get back this? I'll have to multiply sine 2a by minus 1. I'll get back to that. Okay, so here is the exact same as here. On the bottom then, I'll take out cos 2a. By the way, that was... Now what do I have to multiply cos 2a by to get to 2 cos 2a? Sorry, 2 cos 2a cos A, I'll have to multiply it by 2 cos A. As you think about it, this here, cos 2A multiplied by 2 cos A is the same as this, 2 cos 2A cos A. And then to get minus cos 2A, multiply by minus 1. Right. This will cancel with this. So I'm left with sine 2A over cos 2A, which does equal tan 2A. So I can say tan 2A equals tan 2A, therefore we've proven it.